Welcome back. In this video, we're going to prove that if a is strictly bigger than 0, then a plus 1 over a is greater or equal than 2. Okay, that means the sum of a number and its inverse is always bigger than 2 or equal to 2. It's equal to 2 in the case when a is 1 and therefore 1 over a is 1, and this means that we have 1 plus 1 is 2. Okay, so we have the equality case when a is 1 over a is 1. Okay, how we're going to prove this result here? The key is that we know from algebra that given any x and y, we have x minus y squared is x squared minus 2xy plus y squared. And this is greater or equal than 0 because it's the square of the a number, or the difference of x and y. So this is, think of x minus y as a number, and it's squared, and therefore it's positive, and it's bigger or equal than 0. Okay, so here we can use this fact here. Okay, so but in our case we have the a is positive, so we're going to use this one here, but we slightly modify, we're going to modify it a bit to make it look like this. Okay, so if a is positive, therefore we can define the square root of a, and we can also define 1 over the square root of a. Okay, because it's never 0, because a is strictly bigger than 0. If we can do the following, square root of a minus 1 over square root of a squared, so this is always positive. Okay, as we said earlier, so we can use this fact here, and we can write this is square root of a squared minus 2 times the square root of a times 1 over the square root of a plus 1 over the square root of a squared. A is positive, so we have only a, minus 2 square root of a times 1 over square root of a is the square root of a over the square root of a, which is 1. Therefore, we have 2 times 1, which is 2, plus 1 over the square root of a. A is positive, so we have only a, 1 over a. But this one here is positive, as we said earlier. This is a square of a number, any number. So it's always positive. So here we have the square root of a minus 1 over the square root of a. It's bigger than 0. And we know that this is just this one here. Therefore, we have a minus 2 plus 1 over a greater or equal than 0. Okay, if we add 2 to both sides, we're going to have a plus 1 over a bigger than 2. Okay, and this is what we need. So this is the result that we need. So we showed that the sum of a positive number and its inverse is always greater than 2. Okay, so this is one way. There is another way. So to prove this result, a is positive. So we have a is positive. Okay, so we have a positive, and we want to prove that a plus 1 over a is bigger than 2. So we can multiply everything by a. The order is not going to change since a is positive. So let's multiply by a. We're going to get a squared plus 1 bigger than 2a. And we add minus 2a to both sides. We're going to have a squared minus 2a plus 1 bigger than 0. Okay, and if we see that this is just a minus 1 square, so this is always true. Okay, so this is always true. Or we can start from here. Okay, another way is that we can start from here. We say that we know that a minus 1 is always bigger than 0. Okay, so therefore we have a squared minus 2a plus 1 is bigger than 0. Okay, so if we add let's say how are we going to do that? If we add 2a's to both sides, we're going to have a squared plus 1 is bigger than 2a. Now a is a positive number. Okay, so a is a positive number. We can divide by a, so we get a squared over a is a plus 1 over a bigger than 2 over a, which is 2. and therefore we have result. So this is one way of proving this result. Okay. So we have tried to manipulate this one in different ways to prove that if A is positive, the sum of A and its inverse is always greater or equal than 2. Okay. Thank you very much. Please like, share, and subscribe for more.